Okay, so we have a question here. It says, hence, using the partial fractions obtained in question C above, evaluate the integral of x cubed minus 2x over x squared 3x plus 2. Okay, so basically we have to integrate the partial fractions here. So each term needs to be integrated. All right. So we're going to start with the first term. We're going to integrate x. So x, when you integrate it, remember this is x to the power 1. Okay, so it's going to be x to the power 1 plus 1 over 1 plus 1 minus, or even this 3 here. This 3, every single term is going to be integrated. Okay. So even this 3, we're going to integrate it. So since it hasn't got a letter, it's like saying 3x to the power 0. Remember, colleagues, x to the power 0 is just the same as 1. So when you see a number without any letter, you attach an x to the power 0. Okay, then what you do, you add a 1 over 0 plus 1. Okay, any questions on that, colleagues? When a number, as I said, integration and different integration is like the reverse of differentiation. With differentiation, the number disappears. Now with integration, the number gets a variable. Okay. Then we have plus, so we're going to say plus. Then we need to integrate 1 over x plus 1. So here we cannot use u substitution. All right, so we're going to use this law here. The integral of 1 over x plus a equals the natural log of x plus a divided by the derivative of x plus a. So basically, the denominator, we're going to give it, attach a natural log to it. And again, the denominator, we're going to derive it. So here, this x plus 1, in the numerator, we just put natural log. So it's a natural log. We put x plus 1. In the denominator, we derive x plus 1. Colleagues, if we derive x plus 1, what do we get? When we derive this x, what do we get? And this 1, what do we get? A 1. Plus, mhm, mhm. Or this the absolute value. So these two straight lines. Yes, absolute value. You ignore negative signs. Negative and positive you ignore. Remember from our lesson of price elasticities of demand? Remember the price elasticity of demand, we're getting the absolute value where we just ignore the negative sign or the positive sign. Yes. Plus 4 over x plus 2. So here again, we put a 4 in front. Then the natural log of x plus 2 divided by, so when we derive x plus 2, we derive this x that is a 1, and this 2 disappears. Then you add a plus c here. So x, so here 1 plus 1, that is 2. So we have x to the power 2 over 2 minus 0 plus 1, that is 1. So we have 3x over 0 plus 1, that is 1, plus, here since our denominator is 1, you just write natural log x plus 1 plus 4 natural log x plus 2 plus c. And that is your answer. Yes, because as I said, for example, madam, let's try to use U substitution for this one. If we try to use U substitution, let me just show you what will happen if you use U substitution. All right, the integral of 1 over x plus 1 dx. Okay, so you say let u equal x plus 1. We derive u, so here du. When you integrate this x, it becomes a 1. Okay, and here dx. All right, so we substitute. So it's 1 over u, the dx becomes du. Okay, so 1 over u is the same as u to the power negative 1. Remember laws of indices, colleagues? Okay, 1 over u is the same as u to the power 1. So if we integrate u now, add a 1 here, add a 1, here it's negative 1 plus 1. So negative 1 plus 1, that is 0. So you have u to the power 0 over negative 1 plus 1 is 0. Now, colleagues, whenever you have a 0 in your denominator, that answer is undefined. Okay, so you can say, okay, u to the power 0, that's the same as 1. So 1 over 0. So you have an undefined answer. So that's why we couldn't apply it to these two here. Okay, if it was x plus 1 squared, we would have applied U substitution. Even if it was x plus 2 squared, we would have applied U substitution. But here, We cannot apply it. That's why this law came. That's why this law gets applied there. Hmm. Which numbers here? Eight. If these ones, remember when we broke this one down into partial fractions? Yes, it's the same one. Yes. And is this magic? This is Mr. Moba a magician? No, I won't lie. Integration is confusing, colleagues. That's why I need to give you at least 10 practice questions for integration because it gets confusing. It is very confusing. But the more you practice, the better it is. Differentiation is easier, but integration, as you can see, they use substitution and thing. At first, yeah, it may look intimidating, but just practice. Okay. So, madam, that's where this law came from. Okay, madam, we couldn't use substitution in these cases here. You get an undefined answer. Any questions, colleagues? Yes, it's okay, madam. It's okay. So have you seen when you integrate 3, it becomes 3x. When you differentiate 3x, it goes back to 3. That's how integration and differentiation are related. Okay. Are we enjoying calculus? Let me start with Madam Sylvia. Are you enjoying the calculus lesson? Madam Yvonne, are we enjoying calculus? No, this one is shorter than binomial. There are 10 marks each. So are you willing to leave a 10 marks for that? Okay, if you see, I said yes, it's good. They are coming as compulsory. Yes, yes, this is compulsory. They are coming as compulsory. This one, binomial distribution and Cramer's compulsory. Yeah. Okay, they're not compulsory though. They're not. They're not. Now, this video you need to watch it at least 2 times at least. And also, I said I need to give you practice questions because in one question there are so many rules that have been applied. That's where the confusion is coming from. In one question, so many rules have been applied. Okay, so do not worry, Mr. Chimonia. You'll be okay. All right. This is how it starts. It starts with confusion, then understanding. Okay. So are we ready to get confused again with this next one? Are we ready to get confused again? Hmm. Oh, oh, yes, you can ask. Okay, where once? Mm. Mhm. Oh, that was that. It was the second one. The second one, right? Mm. Was it? Okay. I'll check in the board. We'll get back to it. Yes, but I have an idea of where you're talking about. Yeah, I have an idea. We'll get back to that one. Okay, madam? Yes, it's a promise. Who is it? Who is it? Ah, okay, okay, Madam Sylvia. Yes, yes. Promise we're going to go back to that. Yeah. Because I've seen people and that in their minds have told themselves this question, why even waste my time? Colleagues, as I said, this one now is 10 marks and it's compulsory. Okay, so remember this one, it broke down to 1 minus 2 over x plus 1 plus 1 over x plus 1 squared. So we are integrating each of these. We're integrating this 1, we're integrating this 2 over x plus 1, we're integrating this 1 over x 1 over x plus 1 squared. Okay, so we integrate. So as I said, when a number remains by itself, okay, you always attach an x to the power 0. Okay, so you add plus 1 over 0 plus 1 minus, okay, so here we've got a linear factor x plus 1, so we are applying this rule here, 1 over x plus a, natural log x plus a over derivative of x plus a. So here we're going to just put first the 2 here, then you say natural log x plus 1 over. So when we derive x plus 1, we derive this x, you get a 1. You derive this 1, it disappears. Plus, now for this one here, you can't apply this natural log thing. This one here, we can apply u substitution. So let's take it to the side, we separate it, okay, and apply u substitution. So with u substitution, first step, determine your u. So you say u equals x plus 1. Derive u. So du, when we derive x plus 1, that is 1. Then you put dx here. All right. So it's a matter of substitution here. We say 1 over u squared du. Okay. The dx has become du. The x plus 1 has become this u down there. So according to the law of indices, 1 over u squared is the same as u to the power negative 2 du. Then we integrate now. So you're going to say negative 2, always add a 1. So negative 2 plus 1 over negative 2 plus 1. Negative 2 plus 1, that is negative 1. So you have u to the power negative 1 over negative 1. I hope it's not sounding like Greek. Okay, I hope the English never stopped when the integration started. Are we okay with this, colleagues? Any question? Any questions? I think I should have been doing that before I move further. I should be asking any questions. Colleagues, any questions here? This is a U substitution. So this is how you do U substitution. Okay. You are trying to put your expression like you are just dealing with one letter. That's what's happening here. Your expression that you have been given, you want to put it as a letter so you can integrate easily. Yes. Then at the end, when you get your answer, you substitute back. Very compulsory, Sam. Very compulsory. Okay. So this u to the power 1, it comes down here. Okay. Because remember, u to the power 1 equals 1 over u to the power 1. Okay. So in our numerator, we have a 1 over negative 1 u. This u to the power negative 1, according to the laws of indices, let me actually bring the laws of indices because they're on this board here first. Okay, let me just bring the laws of indices. So have you seen this law here? A to the power negative x equals 1 over a to the power x. Okay, this is the law we are applying here. Okay. Okay, where was my solution here? So, sir, that's the law we applied here. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay, so that's why the u has come down. Okay Okay, so that's how the u has come down here. This is the power negative 1. That's how it's come down here. So we rewrite our answer as negative 1 over our u. We substitute it back. U is x plus 1. Yes. We just write it back. So as we say, the concept with u substitution, that expression which are given in a bracket or in the parentheses, you want to just put it as a single letter, because when you have it as a single letter you can integrate it easily. Okay, if you have it as a single letter you can integrate it easily. Okay, yes. So this here, this 1 over x plus 1 squared now becomes negative 1 over x plus 1. It's it's gone up. It's gone up, colleagues. If you want, you can leave it below here. You can leave it like that. But to make your answer look nice, okay? To make your answer look nice, it's good you put it on top. It doesn't change the meaning, okay, madam? The meaning doesn't change, okay, madam? So that negative, we've just brought it up here. Okay, if you leave it in the denominator, you even usually see in a lot of maths books, they will rarely leave the negative in the denominator. They will usually bring it on top, or they'll bring it before the fraction. Okay, you can bring it also before the fraction. So this same negative here, when it meets this positive here, it becomes negative. Okay, that same negative sign, it comes in front now here. Is that okay, Madam Sylvia? Okay, it's not magic, it's not trickery. Yes, it's not trickery, okay, madam. In the exam, you won't lose marks. You won't lose marks, okay, madam. You won't lose marks. Yes, sir. I was saying the negative. Sir, your answer won't look nice if you leave the negative down. It won't look presentable. It's about looking nice, sir. The answer has to look nice. Okay. Yes. There was someone who said hello, sir. Yes. There's someone who wanted to ask a question. Okay. Let's see. Can all of you mute your mics? Just mute your mics, everybody. Okay, madam, if you're not hearing the echo, just do a thumbs up. Whoever is not hearing an echo anymore, just do the thumbs up. Okay. Okay. So I think I don't know what causes this echo, but let me just finish up the question, then you can ask questions, all right? Let me just, because we're done with the question here, then you can ask what you need to ask, all right? So this becomes 1x here. This 0 plus 1, that is 1, so we have an x there, 1x. 0 plus 1 in the denominator becomes 1, so 1x over 1, you remain with a 1x. Even here, 2 natural log x plus 1, this denominator goes. So your answer is 1x minus 2 natural log x plus 1 minus 1 over x plus 1. That is the answer. Now you can ask your questions. Oh, plus C. Please put a plus C here. You lose 2 marks for not putting it. Now, yes. This is where you're free now to ask any questions. Or this is where we can start now practicing integration.